Let's take a look at doing the reverse. We had the z-score and we found the area under the curve. What do we want to go the other way? What if we have the area under the curve and we want to find the z-score? Something that's often used in the medical field and other fields when we're dealing with things like percentiles, or we know the percent and we want maybe some other information. So what is closest to your area? And you might not find it exactly. We do want to look for the closest. We want to find the corresponding z-score. Find the score such that the area to the left is 0.1. So we go over to our table right here, and we're looking for something as close to 0.1 as we can get. You notice they are kind of in order, which makes it easier to sort. We start out with really small numbers and they get bigger, so I can kind of look and say, oh, I've got some 0.1s in here. How close to 0.10 can I get? Well, this right here .1003 looks about as close as I'm going to get. So I want to read the corresponding z-score. Remember, your first two digits were your row, so I'm going to go out to my first two digits. It's that row, negative 1.2, and my last digit is my column. I go up to the column and it's 8. I want to put these numbers back together. First two, last. First two, last. I put them back together and I have negative 1.28. Find the z-score so that the area to the right is 0.025. You got to think here. You got to be really careful. We have the right. Remember, the table only gives the values to the left. Uh-oh, what do we do now? We don't panic. We say, hey, I can find the left just by subtracting from 1. They are opposites or complements. So this is really the same as asking, find the z-score so that the area to the left is 0.75. They mean the same thing. We go on our table and it's kind of like a treasure hunt. We're hunting for numbers close and inside the table, close to 0.75. How close can we get? And we sometimes it comes down to two that are really close. For example, here we have 0.7486 and 0.7517. They're both about the same distance apart. Technically, 0.7486 is just a tad closer than 0.7517, but really, if I would take either of those because it's kind of they're really, really, really close. So we want to go and put the z-score back together. So we find the corresponding row. Oops, hate it when I do that. Corresponding row, let's see what I was doing. I was doing 0.7486. Corresponding row is 0.6. Corresponding column is 0.7. If I were to put those back together, remember first 0.06, last 0.07. First, last. Now, if you told me 0.068, well, I'd probably still take that because it is such a close call. 0.67. Now let's look at some funny notation. We have this notation z, we call it z sub alpha. Z with the little alpha symbol here can be read as find the area under the standard normal curve so that the area to the right is whatever the value they have filled in. For example, find z 0.10. Now you have to keep in mind this notation or this particular set of z and the subscript means to the right. The table only gives to the left. So I do have to subtract to figure out what I'm looking for on the table. Now people's most biggest mistakes is they'll go ahead and they'll say, hey, z is equal to 0.90, and they'll look up the area. But remember, this is the area. This is the inside of the table, and we want to find the corresponding z-score. So we're looking for close to 0.9 here. I think 0.8897 is about as close as I'm going to get. 0.8897. It's just 0.0003 shy, and that z-score corresponds to 1.28. First two digits, last digits. So that z would be 0.128. Be really careful with your positives and negatives, and be really careful realizing what you're finding. Do you have the z-score and you're looking for the area, or do you have the area and you're looking for the z-score?